Hi, and welcome back. Today we're going to do section 8.3, which is on product sum identities. Now, in this section, there are quite a few other identities that you are not responsible for. So the ones that are on these notes, these are the ones that you need to know, memorize, and be able to work with. So we're going to start with the double angle identities. Okay, so these you do need to know. So we only have one double angle identity for sine. So the sine of 2 theta, which by the way, whatever is in here, you can't break up. So we'll talk about that in a minute. So we have to use this formula because you can't just take the sine of theta and double it. That's not what this says. This is the sine of 2 times an angle, okay? Not 2 times the sine of theta. That's totally different. So if you have a problem like this, you have to break it up into using this identity, which is 2 sine of theta cosine theta, because we know how to take the sine of theta and the cosine of theta using the unit circle or using right triangles, but this we do not know how to do. So we use the formula to figure that out. Now for cosine of 2 theta, so that's why these are called double angles, because we're doubling the angle, okay? So you have 3 different formulas to know to use in your work. It's good to memorize all of these because for one reason or another, one might work better. If you only memorize one, you could probably get through a problem, but it might be a little bit harder. So it's a good idea to kind of learn all 3. And then we have the tangent double angles, which this is the actual double angle formula down here. I added this one because you can do the tangent of 2 theta as the sine over the cosine of 2 theta. That's always how you find tangent. So if you're doing a problem where it asks you to find the sine of 2 theta and the cosine of 2 theta, then if you're asked to find the tangent of 2 theta, instead of doing a whole new formula, you can just divide your 2 answers that you got previously. Okay, but either of those will work. Sometimes you don't have the sine and cosine, so then you would want to do this. So it just depends on the problem. All right, so we're going to work with the double angle identities first, and then the other identities you're responsible for from this section will be the half angle identities, which we'll get to in just a little bit. Okay, so here's some of the problems that you'll need to be able to work out. So the first one says, find the sine of 2 theta, given the sine of theta is 5 over 13, and the tangent of theta is less than 0. So this is just helping you decide what quadrant you're in, okay? So if you think about where the sine of theta is positive, the sine of theta is positive where the y value is a positive value. So your y is positive here, right, plus plus, and then here it's negative plus. So these are the only 2 quadrants where this angle could possibly be. So they're also telling you that the tangent is negative, less than 0. So for the tangent to be less than 0, that would need a positive over a negative number. So we're talking about this quadrant right here, okay? So theta can't be in the first quadrant. All right, so if we know that the sine is in the second quadrant, I guess I shouldn't have wrote that too big, but let me come over here. So now we have an angle, theta, over here. So we know we're in the second quadrant, and the sine is 5 over 13, which is the opposite side over the hypotenuse, right? So we would have to figure out this side using the Pythagorean Theorem. So we would do 13 squared equals 5 squared plus b squared. So you can work that out, okay, but you're going to end up getting that side to be 12. And because we're going left, that would be a negative 12, right? So the cosine over here is going to be a negative value. So again, do your Pythagorean Theorem. I'm not going to work all that out. You guys have done this enough, but it would be, right? That's how you would set it up, and you should end up with b squared equals 144, so b would be 12. All right, so now I can tell you that the cosine of this angle would be adjacent over hypotenuse, negative 12/13. So why am I finding the cosine? Well, remember your formula for the sine of 2 theta. This is hugely important, and a lot of you will make this mistake. When you're asked to find a double angle, you're not doubling the sine value. Remember, this is the sine of theta. This is not theta, okay? So if you're asked to find the sine of 2 times theta, I don't know what theta is to double it. There's nothing for me to double here, so you can't double that. So that's where this formula comes in up above, okay? So the formula for the sine of 2 theta is 2 times the sine of theta times the cosine of theta. why I was finding the cosine, because I know that I'm going to need it. Well, I know these values, so now I can do that. 2 times the sine of theta, which was 5 over 13, times the cosine of theta, which we just found, negative 12/13. So now I can multiply that all out. So 2 times 5 is 10, times negative 12, that's negative 120, over 13 times 13, which is 169. So that is the sine of 2 times theta, which is not 2 times that, right? Doesn't come out to that at all. So again, we're finding the sine of a double angle, which we have to use a formula for. Okay? All right, good example 2. This one's asking us for all 3 double angles for sine, cosine, and tangent. And all we have here is that the tangent of theta is negative 5/4, and theta is in quadrant 4. All right, so if theta is in quadrant 4, here's your angle on your triangle. Okay, and since we have the tangent, opposite over adjacent, so opposite 5 over adjacent. And since you're going right, 4 would be positive. Going down, 5 would be the negative number right there, right? So get you the negative 5/4. Then we would do the Pythagorean Theorem to find the hypotenuse. So that would be a squared plus b squared equals c squared. 4 squared plus negative 5 squared equals c squared. So that's 16 plus 25. So we end up with 41 being c squared. So c would be the square root of 41, right? All right, so in order to do this, we need the sine of theta, and we need the cosine of theta. So let's go ahead and figure those out, so that way we have them. So the sine of this angle would be the opposite over the hypotenuse, so negative 5 over the square root of 41. The cosine of this angle would be adjacent over hypotenuse. Now, I'm not going to rationalize them yet because in the formula they may end up going away, and so I always wait to the very end to rationalize. It's just extra work that you don't need to do right now. I mean, you could write this as 5 square root of 41 over 41, but you'll see in a minute sometimes they end up working themselves out. So let's wait till we need to rationalize, okay? All right, so we already know the formula for the sine of 2 theta. That is 2 sine theta cosine theta. So the more you know these and learn these, the better off you're going to be. All right, so all we have to do is 2 times the sine of theta, which is negative 5 over the square root of 41. And the cosine of theta was 4 over the square root of 41. All right, so we're going to multiply the numerators. 2 times negative 5 is negative 10, times 4 is negative 40. And the square root of 41 times the square root of 41 actually works itself out. We get 41. Okay? So didn't have to rationalize that at all. All right, now we need the cosine of 2 theta. All right, so we have our choice. You can use any of these formulas you want. It doesn't really matter. Okay? I mean, one's not any worse than the other. So just, I'm going to go ahead and pick. I'm only looking at my numbers. So I'm going to go ahead and do the one with cosine since cosine's positive. So I'm just going to use the bottom one. So 2 cosine squared minus 1. You'll get the same answer no matter which one you use. Okay? All right, so we're going to do 2, put in the cosine of theta, 4 over square root of 41, square it, minus 1. Okay? All right, so first we're going to square, leave the 2 there. So 4 squared is 16, and the square root of 41 squared is 41. Now I see that I'm going to need a common denominator of 41, so let's just go ahead and make 41 over 41. 2 times 16 is 32 over 41 minus 41 over 41. So 32 minus 41 is negative 11. No. Yes. I'm drawing a blank here. It's 9, isn't it? My mind is saying one thing and my pen is saying another one. No, negative 9 over 41. So there's your cosine value. Okay? All right, so here's where I was saying. For the tangent, we've got to do the tangent next. So for the tangent of 2 theta, I could do the formula. Okay? But that's kind of a, I got to do some work there. But since I've already got the sine and cosine, the tangent is always equal to the sine and cosine values, right? So we can just do the sine of 2 theta over the cosine of 2 theta. That would be easier in this problem since I already have them. So the sine of 2 theta was negative 40 over 41 divided by the cosine of 2 theta, negative 9 over 41. So all I have to do is divide these, which means I'm going to flip and multiply by the reciprocal. So negative 40 over 41 times negative 41 over 9. 41s are going to cancel. I got a negative times a negative, which is positive. So I'm going to end up with positive 40 over 9. So there's the tangent of 2 theta. Okay? All right. So again, these problems, you have to use those formulas. You can't just double the numbers. You know, sure sounds easy enough, but that's not what this is asking you to do. Okay? All right, so moving on, a couple other things with these double angles. So now we're going to rewrite each of these as a sine, cosine, or tangent of a double angle, and then we want to evaluate without the calculator. All right, so this is where, you know, these are the formulas. So if I look back at the formulas, they're giving us now stuff on the right side. So we just need to know which formula it is, and then we're going to write it this way. So 2 times the angle. So for example, cosine squared of an angle minus the sine squared of an angle, that's a formula for the double angle for cosine, right? So we're going to do the cosine of 2 times theta. So remember, theta is the angle over here on the right. So this is going to be the cosine of 2 times 11 pi over 12. So that would be on the left side. So multiply 2 times 11 pi over 12, and we end up with the cosine of 2 goes into 12 6 times, so that ends up being 11 pi over 6. So remember, like we did in the last unit, sometimes the numbers on the right side are not on the unit circle, but the one on the left is. So now we know that this expression is the same thing as the cosine of 11 pi over 6, which is on the unit circle. So 11 pi over 6 has the cosine of the square root of 3 over 2. Okay? So it's easier to go backwards when they give you the right side, but you just have to be able to pick it out. All right, so I know that the angle formula that starts with 2 sine cosine, that's the double angle for sine, right? That's the double angle for sine. So we're going to pull it back and say that this is the sine of 2 times the angle, 67.5. So if you multiply 67.5 times 2, you end up with 135 degrees, which again, these are not on the unit circle, but that one was. So find 135 degrees. We're going to do the sine of that angle, which is positive square root of 2 over 2, since you're in the second quadrant. All right. I know this is tangent because that's the formula for tangent. So whatever theta is, we're going to do 2 times it to get it back to the left side. So this will be the tangent of 2 times negative pi over 8. Well, that is the tangent of 2 times negative pi over 8 will give you negative pi over 4. Okay. The tangent of that, remember that's down in the 4th quadrant. So tangent is negative. So that would be negative 1 for your tangent value. Okay? All right, last one of these. Again, that's a cosine, 2 cosine theta minus 1. So I know that I'm going to bring that out into the cosine. So the cosine of 2 times 105 degrees, that would give you the cosine of 210 degrees. That's on the unit circle. Cosine of 210 degrees, 3rd quadrant, so negative square root of 3 over 2. Okay? All right, then you might also be asked to do some proofs using the double angle. So anytime I see double angle, I know I've got to break this up into using one of those formulas. So again, pick the harder side. Let's see if we can get it equal to the easier side. So the sine of 2 theta, I know that formula now is sine of 2 theta cosine theta over 1 minus. Now, I got to figure out which of my cosine of 2 theta formulas do I want to use. So like I told you, you could use any one and they will work. It might take you more steps than the other one, okay? But because I see that I need cotangent over here, cotangent means I need cosine over sine. So I want to pick the one with sine in it because I most likely want to cancel that sine out. So I'm going to use this middle one, 1 minus 2 sine squared. Now be careful because it was a minus sign there, so we got to distribute. Okay, we're changing just the cosine of 2 theta is that. So this is actually going to be minus 1 and then a plus 2 sine squared, right? All right, so in the top, leave that alone. And in the bottom, you'll notice you've got 1 minus 1, so that's going to go away. And then you have a negative, negative, so you're ending up with 2 sine squared in the bottom. All right, so we can, everything now is multiplication. And remember, sine squared means sine times sine, right? So I can cancel these 2's out. I can cancel one of this sign with one of these, because there's sine squared means there's 2. So that's going to go away with one of those. So I'm going to be left with the cosine theta in the top and the 1 sine theta in the bottom. And cosine over sine equals cotangent, which is what I wanted. Okay? All right. So, you know, the double angles are, I think, easier because you know exactly what you have to do with them, whereas some of the other proofs, you're kind of stuck. All right. So let's just start with cosine squared minus sine squared. I don't think it will matter here, but I'm going to go ahead and do that one. Cosine squared minus sine squared. Now, you do need to be careful with this one because remember, cosine squared plus sine squared equals 1. But if it's a minus sign in there, that's the double angle, so be careful with that. All right, over sine theta, cosine theta. So I'm picking this as the harder side. I'm going to try to get it equal to that. All right, so from here it should be pretty easy. So we're going to take the denominator and put it over both. So we're going to break this up because I see I need 2 terms here. So I'm going to break it cosine squared over the denominator minus sine squared. So I'm just breaking up my fraction. Okay. So each of them can be put over that same denominator. And again, I'm looking at what I'm trying to get, and because what I'm trying to get is 2 terms, that's how I knew I had to break this up. I don't want 1 fraction, I needed 2 things. All right, and this is kind of similar to what we did here. I've got 2 cosines in the top and 1 in the bottom, so I can cancel the 1 in the bottom with 1 in the top. So that leaves me cosine theta over sine theta, which is cotangent, and then minus. And now here I can cancel the sine in the bottom with one of those sines in the top. So that leaves me with sine over cosine, which is tangent. So I'm done. Cosine over sine is cotangent. Sine over cosine is tangent. And that's what I was trying to prove. Right there. Okay? All right. Now, you know, on your tests and on your homework, verifying is kind of hard for you to do. Typically on the final exam, you guys will notice that on the multiple choice, they're going to give you some options on what you could do in the steps or whatever. So you do need to practice with these and make sure that you're okay with doing proofs, whether it's for homework or for the final. Okay? All right, lastly, half angles. So half angles are the other identities that you need to know. Half angles are kind of weird because you guys kind of forget that in the formula you're allowed to take half of the angle, which, you know, we just did double the angle, right? We did 2 times the angle. So now they're saying, what if you're given half of an angle that's on the unit circle? So you'll see that in a minute. Like example 5, they're giving you find the sine of 22.5. Well, that's not on the unit circle, okay? But if I double it, which is kind of weird because when you double it, you think, why wouldn't you use the double angle formula? But it's the initial angle that you're looking at. Okay, so you'll see that in a minute. The formulas for sine and cosine are pretty straightforward. They're both the same, except sine gets the minus sign in it, cosine gets the plus. Now, the thing you have to worry about these is you got to decide whether it's a positive or negative answer, and that depends on the quadrant of the angle that's given to you in the problem, okay? Not the angle that you're using here off of the unit circle, the angle you're starting with. So for example, 22.5 is in the first quadrant, so I would need the sign, the SIGN, the sign of sines in the first quadrant, which would be positive. So my answer would be a positive square root, whatever I get in there, okay? Tangent, again, if you have the sine and cosine already, you can just divide those two answers. Otherwise, you've got to use one of these formulas, okay? All right, so here's how this works. So if I look at 22.5, not on the unit circle, if I double it, I get 45, right? So if I look at 45 in this problem and I'm trying to get 22, I don't want to do 22.5 times 2. I want to do 45 divided by 2, okay? So when you look at this formula, theta needs to be on the unit circle. So if I take half of that, that's what's giving me that. That's why it's called a half angle, okay? I'm actually finding the half angle of this using this formula, okay? So kind of think about that. You're using double this angle, but if you start with 45, the number on the unit circle, you're actually getting ready to find the sign of half of that, which is that number, okay? So I've got the sign of 45. I know that 22 is in the first quadrant, okay? So I'm going to put sign is positive in quadrant 1, right? So that's how I get the plus or the minus. All right, so this is going to be a positive answer. I'll put it there. You don't need to put the plus sign, but just so we know we did it. All right, so we're going to do 1 minus the cosine of theta. Well, now theta is 45, so I can do that, and I'm going to divide that by 2. Okay? All right, so that gives me 1 minus the cosine of 45 is the square root of 2 over 2, and I'm dividing that whole thing by 2. So now we got to simplify this. Okay, so we have a couple more steps to go. Good news is pretty much all of these you simplify the same way. So first thing I want to do is get a common denominator here. So instead of writing 1, I'm going to write 2 over 2, right? That's the same thing as 1 minus the square root of 2 over 2, and I'm going to divide that whole thing by 2. All right, so now I have this I can write as, I'm going to leave a little space out front for just a minute, but I'm going to write it as 2 minus the square root of 2 over 2. I got my common denominator, that's the whole top. Then instead of writing dividing by 2, when you divide by 2, it's the same thing as multiplying by 1/2. It's still in the bottom, okay? So instead of having this big giant fraction and a fraction, I'm just going to pull this 2. It's the same thing as writing it that way. So then hopefully you'll see that now we have 2 minus the square root of 2 in the top, and then 4 in the bottom. 2 times 2. Now, the square root of the top, I have no idea what it is, but I do know the square root of 4 is 2. So I can do one more thing. So I'm going to just put the square root up with the numerator, and I'm going to make the bottom 2, because the square root of 4 is 2. So that's the answer. Looks kind of crazy. That's how we work it. Okay? All right, we'll do it again on this one. So let's see what happens with finding the exact value of cosine of 5 pi over 12. All right, well 5 pi over 12 is not on the unit circle, but if I do the cosine of half, or if I double that, I get 5 pi over 6. So I'm going to divide, I'm going to write it like that. Now you could change that to a degree, okay? If you change that to a degree, same thing. So I'm keeping it, because I know if I double it, that just changes the denominator. So half of 5 pi over 6 is 5 pi over 12, okay? 5 pi over 6 is on the unit circle, right? That's 150 degrees. So if I divide that by 2, this would be 75 degrees. So you could change it to a degrees if you wanted to. All right, so look at the angle that you're looking for. 5 pi over 12, 75 degrees. This is in the first quadrant, right? In quadrant 1. So again, my answer is going to be positive, right? Because even though this is in the second quadrant, I'm not finding the cosine of 5 pi over 6. I'm actually finding this cosine. First quadrant, cosines are positive. So again, when I do my square root, cosine will be positive, okay? So the formula is exactly the same, except we're going to put a plus sign in the middle. So we're going to do 1 plus cosine of this angle, 5 pi over 6. And we're going to divide that by 2. Okay. So what is the cosine of 5 pi over 6? That's a negative square root of 3 over 2. So we get 1, and it's plus a negative square root of 3 over 2, so I'm just going to write minus square root of 3 over 2 over 2. All right, so we're going to do the same thing we did. I'm going to put the bottom 2 in the bottom, 1/2. And then this would be 2 over 2, right? Change that to 2 over 2. So we would end up with 2 minus the square root of 3 over 2. So that would give us 2 minus the square root of 3 over 4. And then take the square root of the denominator. You can't take the square root of the top, so leave the square root up there. You got to add the square root to the top, but you can take the square root of 4. So these are like the sum and difference formulas where your answers are going to look very similar. Okay. All right, and then the last problem, this one goes back to drawing your triangles, and we have to do the Pythagorean Theorem. Sorry, paper's messed up. Okay, so we're given the sine of theta is negative 7 over 25, and theta is between 3 pi over 2 and 2 pi. So that means this is 3 pi over 2, and this is 2 pi. So that means theta is in the 4th quadrant. So here's your angle. There's theta. The sine is negative 7 over 25. So opposite, negative 7 over hypotenuse 25. Okay? All right, so we need to find the exact value of the tangent of theta over 2. So look at your formulas. You got a lot to choose from. I could use the first one, which all I need is cosine, which I don't have. All they gave me was sine. Or I could use either one of these. So I always tend not to use this one because of the square root, but it just kind of depends. So let's see what we get for the cosine and what looks easier to put in the bottom. Like right now I'm thinking I might as well just use this one because the sine is just a fraction. But let's see what we get for cosine. All right, so we need the Pythagorean Theorem to find our problem, our answer. So c squared equals a squared plus b squared. So 25 squared equals negative 7 squared plus b squared. Again, it doesn't matter what a and b are, right? You're just trying to find that out. So 25 squared is 625. 7 is 49. So 625 minus 49 gives you 576. Take the square root of that. Oh, what happened if I did that right? All right, and you end up with 24 as b. So this side is 24. Can't see it too good, 24. All right, so cosine of theta in the 4th quadrant is positive. So it's adjacent over hypotenuse, so 24 over 25. Okay. All right, so I don't know, it doesn't really matter which one we're going to use. Since I said this, let's just use this one. Doesn't really matter. So I'm just going to pick 1 minus the cosine of theta. So we're finding the tangent of theta over 2. So that is 1 minus cosine over the sine. Again, you can use any formula you want for tangent. So we're going to do 1 minus the cosine, which is 24 over 25, divided by the sine, negative 7 over 25. All right, so again, 1, you're going to write it as 25 over 25 minus 24 over 25, right? All right, so that gives us, in the numerator, 25 minus 24 is 1 over 25. We're going to divide that by negative 7 over 25. So now we're going to multiply by the reciprocal. So 1/25 times negative 25 over 7. 25s are going to cancel. So we end up with negative 1/7. Okay? All right. So as I said earlier, there's quite a few formulas in here that you need to know. So please make sure you're studying those daily. You're not supposed to have these in front of you when you take your test and the final exam. So please make sure that you're learning these and that you're abiding by the honor code and that you know these before the test comes up, okay? All right, work on your homework. Please let me know if you have any questions.